Well, there's a good afternoon. This is Talks. It happens every Tuesday at 1:30 while school's in session. In the summer, we're going to try to slack off for a month if we can. It's been a lot of fun, and basically we have people out on Adobe Connect out in the world, all over the world watching this. We put it up on our website later so you can watch these videos too. Mostly that works. And then we have it here. And there are people from the community. We have people who find it in the newspaper in Mountain View. And there's usually some faculty and some students. And I see that in evidence today in spite of it being summer, feeling like very much like summer. In any case, the talks have been amazing. People from Xerox and Stanford and CMU and MIT and everywhere good. And today we have a speaker from Cool Iris. What you'll find is we've turned on the microphones on the table in front of you, so if you eat loudly, we'll all be, luckily you don't have crunchies that you're moving around. It'll get projected to everyone. But it also allows you to ask questions, and that's the big deal. So we'll go until 2:20, 2:25, ask some questions if you like, and then we'll go out in the hall and hopefully you'll have some sodas and cookies with the speaker and find out more about Cool Iris. So I ran into Cool Iris because one of our faculty here, Colin Jackson, had a lot to do with doing some of the ports of the big fancy algorithms to some of the browsers. And I don't even know how to pronounce your name, Aneesh Karve?
Pretty good.
Okay. Is here thinking about design patterns for browsing and sharing and privacy. It's an awfully fancy name, but I bet you we're going to learn something about Cool Iris anyway. And really look forward to this. And thank you for coming. And here's your requisite CMU cup.
All right.
Present your.
Is it safe to drink out of?
Yeah, this is, I'm sure not. But it's aluminum so that it doesn't have PCBs or whatever they put in the plastic ones. All right. Not until after the talk, though.
Deal.
Yeah.
Okay. All right, folks, thank you so much for the invitation, and thank you, Ted, for the introduction. I'm just going to tell you very briefly a little bit about Cool Iris. We were founded in 2005, and our goal was to revolutionize the way that people browse, share, and discover media on the web. And people have described us variously. One of our venture capitalists that backs us, John Doerr, said, Cool Iris is a great company. Let me just show you. And so we're going to I'm going to have some product demos today, and I'm going to work that into the topic for today, which is design patterns for browsing, sharing, and privacy. And we'll have some interactive demos. And of course, during the course of the talk, if you have any questions or comments, please feel free to raise your hand, and I'd be happy to entertain your question. So the first thing I'd like to talk about is what exactly is a design pattern. And the thinking around design patterns, whoops, let me back that up for a second. So there's 5 main areas we're going to talk about today. So one is we're going to define design patterns. The next thing, we're going to talk about browsing in general. Then we're going to move on to mobile interaction design and how that's influencing our thinking around media throughput on devices with limited viewports. Then we're going to talk about context. And this is a word you all have heard, content is king. People are now saying context is king. Well, one of the things that I think is missing is a compelling and simple definition. And we're going to solve that problem today. We're going to try at least. And then we're going to talk about sharing and privacy. So back to the first section here on design patterns. This was a movement that was started by Christopher Alexander, and he wrote a book by the name of A Pattern Language. And what he was really trying to do was to codify the elements of good design. And he was looking for, what he noticed, he was actually talking about architecture in his time. And what he noticed is that there were certain archetypal patterns, certain invariants that occurred over and over again. And how many people in here are familiar with the Gang of Four patterns book? Okay, so if you read the introduction to the Gang of Four, they actually give a nod to Christopher Alexander. And he really got them to think in a methodical way about what kinds of reusable patterns there are in the design world. And now we've seen that this design pattern movement, with the explosion of interfaces being created for the web and for mobile devices, people want reusable patterns that cut their work time down. And we're now seeing design patterns move over into interaction design. Is everyone able to hear me okay? Yeah. Okay, good. So before Alexander published a pattern language, he published a much shorter and very to-the-point book called Notes on the Synthesis of Form. And back in the 1960s, this was actually required reading for computer science departments. And as we see through the Gang of Four example, it heavily influenced programming languages, software engineering, and of course, the thinking around object-oriented programming. And the central thought here is that a form is an image of the ambient forces, or the forces, the contextual forces that surround that form. And here, if you're familiar with ferromagnetic liquids or not, the idea here is the shape that this form is taking is a function of the fact that the field that it's within is isotropic. The field is non-homogeneous, and this drives the shape in the form. And I want to go through some very common everyday examples that illustrate this general principle. So those of you who are familiar with the human-computer interaction literature know this concept of desire lines. And what this does is this desire lines show us where people continue to grip objects. And this gives us a sense of where the human being is coming in contact with the form. And then if you start to examine the hammer, you look at the tip, for instance, and you see that there are chips due to friction or due to impacts. And where the natural forces record themselves on the form or the object of our design, that's where we start to see whether or not our form has a good fit with its context or with its environment. And another and very beloved example of mine is the cow path. Does anyone see the cow path in this picture? Yeah, so that diagonal line there, and although people claim that they're afraid of math, what you'll see is that their feet actually understand the Pythagorean theorem quite perfectly. This is an aerial shot of the Dartmouth campus, and you see that cow path is that line right through the middle there. And what this shows is the difference between the paths that were intended or designed and the actual paths that people take through the everyday world. And what Alexander says is that there's a multi-stage design process, and I've broken it down here into 5 steps with an acronym, SARIO. So, and we're going to talk about each of these in detail, but very briefly, you set the boundary between the form and the context. That's the setting of the problem. Then you analyze the forces acting on that form, and then you resolve the related forces with diagrams, instantiate a resolution, and finally observe the points of friction. And that's what we just saw with desire lines and with cow paths. That's the friction that's between the real world and the design, between the context and the form. So I want to talk about point number 1 for a second here. But first, I want to give credit to Ryan Singer from 37 Signals, who in recent memory I think has done the best job of really taking Christopher Alexander's work and making it palatable to a modern audience. All right, so the first thing is the form context boundary. So here this line kind of represents the boundary between the form that we're designing and the context that it has to live in. And there's a tremendous opportunity for innovation at this very first step, and I want to kind of draw your attention to that. Sometimes we focus so heavily on problem solving that we forget that we have the power to set the problem. And the example I want to give is a quotation from Henry Ford and subsequently from Steve Jobs, which says, if I had asked my customers what they wanted, they would have said, build me a faster horse cart, right? But that's a very constrained way of thinking about the problem. And another way of viewing how you draw the form context boundary is this. You can think of problem setting as where you drill for oil, and problem solving as how you drill given a certain location. But the problem is much more general than that, or the framework is much more powerful than that. Problem setting includes asking very broad questions as what is the appropriate context, where should we draw the boundary? In other words, should we be drilling for oil at all? Is that distinction clear, right? So there's where you dig, there's how you dig in a given place, and then should you even be drilling for oil at all, right? And the idea here is that we have a mindset, Maslow put it this way, he said if all you have is a hammer, you tend to regard everything as a nail. And so as engineers and designers, we have a problem-solving mentality, but there are times when instead of solving the problem, we can dissolve the problem by changing the form context boundary. And so just a quick point on the last step there, which is observing the points of friction. I think it's very clear that Alexander was onto a very apt metaphor, because when you look at cow paths and when you look at desire lines, those points of frictions that indicate the misfit between the form and its context are actually literal physical points of friction as well. So it turns out to be a very powerful metaphor. So what I want to do now is kind of take the space of browsing, talk a little bit about some of the research that's been done in that area, and see if we can break it down into some reusable patterns for everyday interaction design. So, and when we talk about browsing here, I mean browsing in the most general sense of the term, to include searching, sorting, filtering. And the problem is actually very easy to state, although non-trivial to solve, and that problem is we have more stuff than we have space for. So back in 2008, Cockburn et al. Did a survey paper which looked at 4 very broad categories of techniques for solving this problem of having more stuff than you can display, given the viewport and resolution of your device. And they broke it down into 4 areas. So one was overview plus detail, next zooming, focus and context, and finally cue-based techniques. And I want to briefly look at and give you examples of each one of these, and also explain the subtle differences between them. So the first idea here, this is an example of the overview plus detail pattern. And you'll notice that what you see here is the overview here, and separately the detail. And the important feature of this pattern is, first of all, that the overview and the detail are co-spatial. They occur within the same view, and that no effort is made to actually minimize the edge between the overview and the detail. So contrast this spatial multiplexing technique to this temporal multiplexing technique, which you all recognize as zooming. So the idea in zooming is that the overview temporally precedes the zoomed in view or the detail, right? Very clear. And then we have something which tries to be co-spatial and co-temporal, and at the same time to display the detail in its broader context, to display the focus and minimize the seams between the focus and the context. And this is an example of a fisheye lens, which is a focus plus context technique. Any questions or comments so far? All making sense? Cool. Okay. So, and the last category is something called cue-based techniques. And this is a very simple idea. It's also known as brushing and information visualization. And the idea here is that we take the elements of the result set and we foreground them somehow. So here we use depth of field, which is actually pre-attentively processed. People can very quickly pick out objects that are in focus versus out of focus. Here, you'll notice that the elements of the result set that fall out of the viewport are given this halo. And this halo makes a subtle mark on the edge of the screen such that the degree of the arc tells you how far the hit that's not in viewport is from the focus. Right? So that's a couple examples of 4 techniques. Right. You wanted me to explain this a little bit more? Oh, cool. So the idea is that, let's say we're looking for gas stations, right, which may or may not be the actual example, but it'll serve. And the idea is that there will be some gas stations that are within the viewport and some gas stations that actually fall outside of the viewport. And so now the question is, if you want it to be truly not just a focus plus focus technique, but a focus plus context technique, how do you show the results that fell outside of the viewport? And the idea here is that we draw a halo around all of the results that fall outside of the viewport. And then the user now has a hint. And the arc, the degree of the arc or halo that falls on the edge of the viewport tells the viewer how far away the results that are out of viewport are from the focus. That's the idea there, yeah. Please.
So your examples are visual, so that talking about considering the person involved, in this case a single person, not a group, that it's their visual. There's no mention here, say, of short-term memory or movement from short-term memory to medium-term memory, and the issues like that. It's a visual presentation, single sensory modality, and with a dynamism that isn't yet acknowledging internal aspects of the participants.
It's very interesting that you made that point, because what we're actually in about, I think, 2 slides, actually a couple slides after that, we're going to look at the focus plus context structure of stage processing. And that's a very important point, and we'll actually motivate that from some results from the literature. And so here, again, the idea, so we've seen the 4 techniques, and the results are not exactly conclusive. So it turns out that there's no clear winner for a given problem. And if we want to have a design problem, we want, given a particular problem, where we have more stuff than we have space to show, which technique do we pick? But there's a glimmer of hope. Just recently at CHI 2011, Jacobson and Hornbeck showed that focus plus context might be a disadvantaged technique for small displays. But I think we'll need to see more results and really look very carefully at the experimental design before we can draw that conclusion. So now here's a more general framework that George Furness introduced in 2006. And what he said is, wow, the how of how we visualize information is actually really complex. And Furness comes out and he says, let's forget about how we're going to show things and just focus on what we show versus what we don't show. And his realization, as we just saw with all this plethora of techniques and no clear winner for actual usability, we saw that in scientific visualization, the transfer functions, or in information visualization, the schemas that take you from data to marks are totally non-trivial to develop. And so a simplification of the problem is, let's forget about how and just focus on what to show. And Furness has a nice mathematical formulation of this that we're going to look at here, and we're going to return to this pattern throughout our talk. So the first thing that he does, he defines this concept of a degree of interest function, which is how interesting something is to a given user. And this is contingent on two variables. First, any element in the universe, right? And then what the current focus is, represented by dots. So we've got x, which is any element, and then we've got dot, the focus. And he breaks that down into a function with two parts. He simply says that that, in general, is a function of the a priori or global importance of x and the distance between x and the current focus. And we're going to look at some very specific examples in a minute. And then he defines the answer to the question of what you show. You show all of those things which are interesting enough given the current focus. And enough is set by this variable c. So as we raise the threshold c, we're starting to filter out the set of visible items. And here's a quick example. I just want you to focus on the first three pieces there. So first is we have some kind of understanding, some ranking of the a priori importance of all the elements, right? And you'll see that A and Z are kind of the most important letters. And there's kind of a decay function as we go towards the center of the alphabet. The focus, however, here is towards the middle. And the next thing that we plot is the inverse distance, because what you expect is that as your distance increases from the focus, things are going to become less important. The sum of those two things, the simple sum of them, is an example of a fisheye degree of interest function. And then C then becomes this cutoff line here, which determines which objects you show. And the objects that you show are precisely the objects that fall to the right side of the line. Yes?
Do you also think about cognitive distance? Because these perceptual things are sometimes even secondary, given if somebody has a strong task orientation.
Yes. So there was an important question. It's like, what are we talking about when we're talking about distance? Do we consider cognitive distance? And what I want to say is yes, this distance function is used in the most general way. It could be physical distance on a map. It could be semantic distance between Google search results, but it's an important realization. And this formula is very powerful because it's generic, but it's also weak because it's so generic, right? But the idea is we can plug in any distance metric that we want here. That's a good point. So, so I want to just kind of focus on these left-hand side things here, and hopefully we've done a good job of motivating how the fisheye degree of interest function tells you which elements to show in a visualization. And all I want you to get out of the right-hand side here is that there are a totally non-trivial and explosive number of ways to actually spatialize that result set, right? So here is, you take all of the hits, and you preserve the original topology, but now you're not very efficient in your packing. Here's an example where you smash everything together, but you lose the context of what was present between the letters, L and B, for instance. Here's one where you show elision, and finally here's one where you map the importance to the size, and so on and so forth. And that's the entire field of information visualization, is given a semantic, how you spatialize something. But we're right now concerned with this. What do you show? All right, so now what I'd like to do is do a quick product demo. And we took this problem at Cool Iris. Hey, there's a lot of stuff out there on the web, and it's getting worse every day, or it's increasing, maybe getting better depending on how you look at it. And people need a high throughput way of going through their media. And I'd like to do a quick demo here of one of our first products. Okay, so hopefully that gives you a sense of what it looks like. Looks like we have an echo. Done, thank you very much. So now you have an idea of what it looks like to productize a focus plus context thinking around focus plus context browsing. And of course, everything you saw there was hardware accelerated. It's a big part of our engineering effort was to make it so that it was really fast and responsive to fly through that result set. And in the marketplace, we've gotten a lot of credit for this. We have about 50 million downloads. It's available for a variety of web browsers, Firefox, Chrome. And currently, we serve through what we call the Cool Iris wall and related products about 550 impressions a second. So we've done something right. And now there are some broader product questions to ask. How do we monetize and stuff like that? So without losing sight of what we've said, what I want to do is kind of close up this first pattern, and I promise to move on to the stage processing and cognitive aspects that we discussed earlier. And essentially, the central problem here was that we had more content than we had space in our viewport. And the forces at play here, to go back to the Christopher Alexander metaphor, are the a priori importance of the elements, how much global importance they have, and the distance between those elements in the focus. And then we looked at a handful of techniques here. And the nice thing I think about the furnace framework is that it takes all of these techniques and forgets about exactly how you're going to do the visualization and focuses on what you show. And what you show is all of the things that are sufficiently interesting. And we've already gone through the formulation of that. So now I want to use this concept of shrunken viewport or constrained viewport as a segue to our next topic, which is mobile design. And the observation that I want to make some simple observations here. So first is that mobile is doing something right. Yes. Oh, thank you. It's like a fly. I'll enter my password there. No, no problem. So let's see. Good. Yeah, I think so. Okay, so the point that I want to make here about mobile is something is happening. There are significant causative factors to the explosion of mobile growth, and I just want to very quickly, you probably already know this, at least intuitively, but in 2011, a very important inflection point was hit. And this is the first year in history where the number of smartphone plus tablet units that are shipped significantly outstrips the desktop and notebook total units that are shipped. So we're looking at about 500 million, half a billion smartphones and tablets, and about 400 million desktops and notebooks total. And this trend is projected to continue, and the gap between smartphones and tablets, desktops, and notebooks is expected to continue. And so the next question, naturally, that we want to ask is, what other effects do we see? Well, we also see this tremendous influence of mobile design on desktop design, and I want to motivate that to you here in a moment. So if you just take this stock, this piece of user interface out from the bottom here, this looks exactly like an iPad. However, this is OS X Lion. And now if you look at the folder opening animation on OS X Lion, which is of course a desktop and notebook operating system, you see that they've taken exactly, pixel for pixel, the folder expansion metaphor from the iPad. And another example here in Mail, the threading model, taken directly from mobile. Needless to say, I don't need audio here. Full gesture support. So the fundamental way that you interact with desktop and notebook computers is now totally changed, and it's changed to a way that was created for mobile devices. This is the important thing. And now, if we go ahead and look at Microsoft's Windows 8 preview, we will actually see that the entire desktop metaphor is built from Windows Phone 7, desktop tiles. Yes, good question.
Do you think those preparations have been tested yet, or is it just fashion? Anyway.
I'm going to diagonally answer that question by saying I think I will have a provocative answer to that in a couple of slides. Yeah. So now it's for you to decide whether Microsoft is copying Windows Phone 7 or copying Apple, but the point is the basic point is there, is that mobile design is not only successful in its own right, but it's doing something so right that it's completely changing the way that we design desktop interfaces. And I want to really look at this phenomenon here for a second. And first, just a quick catalog of the influences. So the complete design of the desktop, which is arguably one of the highest frequency, most visited surfaces on the desktop, is completely changed to now mimic what's happening on mobile. Full screen apps, another one. Touch and gestures. Specific application features like email threading and photo sharing. And finally, this complete reduction of Chrome, which is a partial outgrowth of the fact that now we have natural interfaces that don't require so many affordances and widgets, and is also an outcome of the fact that, hey, when you have a shrunken viewport, you have to get rid of a lot of Chrome.
When you say full screen apps, what are you saying?
I mean that now the desktop operating systems are supporting apps in a full screen mode where all of the window management Chrome disappears and you just deal with the application like mobile. Yes?
What is Chrome?
Thank you for asking that question. So Chrome is just all of the UI or all of the visible surface area that's dedicated to interactive widgets. That's Chrome. and the decoration of that. And the way to think of it is if you have a traditional product like a watch, the chrome is kind of like the decoration on it. Or the places like, for instance, the chrome on a doorknob is where you interact with the product. So that's what chrome is. And since you asked, that's why the Chrome browser was called Chrome, because they wanted the web to shine through and the Chrome to be subdued in comparison. Thank you for asking that question.
So aren't there still significant differences between small phone apps and tablet and desktop apps? The differences in best design practices.
Yes, and we're going to actually, I think when we explain why I think mobile is influencing desktop, then we'll talk about that. Yeah, a lot to say about that.
Could consider, from another point of view, full screen apps are just greedy apps.
Okay.
Potentially.
Sure. All right, so now the question is, so we see this influence of mobile on desktop design. Why is this happening? So there are some obvious answers, but I don't think this succeeds in explaining the whole phenomenon. So cost is one. Convenience is another one, right? It's your mobile phone, the best phone is the phone that you have with you. The best device is the one that's always with you, which is typically the mobile device. Enhanced capability. We've seen now, I don't think Apple could have foreseen the amount of innovation that you would get by packing a bunch of sensors onto the device. The things that people have done with the accelerometer, with the gyroscope, with the magnetometer, really, I think, have exceeded their expectations. And we'll talk a little bit about that. However, this doesn't explain, that explains why mobile is popular. It doesn't explain why mobile is showing us what to do on the desktop. And I want to take what we do know about mobile, that it has an extraordinarily small viewport, and now bring this back to focus and context and talk about why mobile interfaces are on the vanguard of what's more usable. And the issue here is that when you're designing for a very small screen, what this forces the product teams to do is to focus on what to show, which is exactly the question that these fisheye degree of interest subsets were designed to solve. And so what that means, the answer to the question of what you show is you show what's interesting. And what's interesting is dictated by what is essential, what is globally important, and what is relevant to the current focus. And now, if we zoom out, the important realization is here, is that decreasing the size of the viewport has the same effect as increasing the distance to unrelated content. So it's both a semantic, a cognitive, and a design effect that designing for a small screen leads to more focused interfaces. And now if we actually look at the user interface Chrome, what we'll see is that only 12% of the Chrome is dedicated to global functions. Everything else, all the rest of the interface is dedicated to the current focus. So the way to think about this is that the same topic, the same content that we had on the desktop has now been retargeted to a smaller viewport. And we can start to think of mobile as being a semantic zoom, a focus on the elements that are important that we were also dealing with on the desktop. And the way I'd like to phrase that is that it really has nothing to do with mobile per se. It's about having a new and constrained perspective on old problems. And in terms of constraint, we've talked very clearly about the small viewport, but I want to talk about what I think are some of the other forces that motivate the enhanced design effects that we're getting on mobile. So it's pretty provocative, I think. What you notice here is that if you look at the elements that are global in importance, there are three things that jump out at you. So first is your context, as given by your time. And we're going to establish in a moment that time is just one dimension of context. The next thing is the bandwidth of the device. And finally, critical for all mobile devices, the power. And what I would like to suggest to you is that the operant constraints, in terms of the forces that are acting on mobile designs and also desktop designs, but we didn't realize it because we never had to design so tightly to these constraints, are viewport, context, bandwidth, and power. And we're going to come back and talk about each one of these.
One more question.
Yes.
Nielsen argued in a recent blog posting that there's also a how difference. He argued on very small devices, kind of a card-based metaphor, where you have discrete units of content, you move from card to card, you don't do complete random scrolling versus tablets and desktops where it's actually more satisfying to do the arbitrary scrolling.
Okay, interesting. I would tend to see, not having read the article, I would tend to see the card-based interface again as enforcing the focus because you can only look at one element at a time. I think we've gotten sloppy in desktop design because we have so many pixels to play with. And that's
What's interesting is the crosses from what to have.
I see. Oh, fair enough. So now we talked about the constraints, and now I want to talk about the power of a perspective. So earlier in the talk, we talked about problem setting. So where you set the form context boundary has a tremendous influence on the answer that you get, on the result that you get. And so what I've tried to show here is that mobile is driving usability through more focused interfaces, reducing the amount of user interface chrome that's needed, relying on natural interfaces that don't require as much in the way of explicit affordances, and has enhanced context awareness via sensors. The first three, location, acceleration, and orientation, are well known. I think what we can expect in the near future is for the device to record context based on the state of our biological organism, right? When the device, we already have examples of an iPod that can track how fast you're running, right? There's a little dongle, you put it in your shoe. Now, once we are able to measure human engagement through heartbeat and other factors, we're going to have even more powerful contextual factors with which to annotate the data.
Well, you could say that there's a real lost opportunity, or not realized opportunity, in that these devices don't even know if their operator is awake or asleep, for instance.
I think that's a good example.
Let alone things like driving a car versus not, or standing at a podium versus sitting down here where we can use keyboard, on and on.
And then I think the next immediate question is, do we want our devices to know these things? And the answer is, I think from the standpoint of the user experience on the device is yes, but now do we want other people who potentially have access to data on the device? We want them to have that, and that becomes a difficult question, which hopefully we'll say a little bit about when we get to privacy. So the important thing here, and this is the core of the pattern, is that because of the constraints in context, viewport, bandwidth, and power, the mobile designs have done a better job of matching the capabilities of the human cognitive system to the capabilities of the device, right? So, and this starts to get into your question about stage processing theory. Human perceptual and cognitive systems are constrained and are easily overrun. And the lesson here is that if you take any one of these four forces and constrain them down as a design exercise, you have a very good chance of doing a better job of meeting people's natural cognitive abilities. So the solution here sounds trivial, right? Designed for limited memory, vision, and attention, and add contextual information, add contextual clues. But now we have a very concrete way of doing it. And that way involves constraining any one of the four factors that we talked about, right? And so I see some folks in the audience laughing. Next up, porting Visual Studio to Windows Phone 7, right? So we're going to talk about what the difference is between tasks that you can do on desktop devices versus mobile devices is. But what I want to present this to all the researchers and product people in the room is that even if it makes no sense to bring Visual Studio to Phone 7, they should do it as a design exercise because the desktop interface will improve as a result. Because the simple fact of the limitations of designing for a small viewport will drive desktop improvements, as we've shown.
And next AutoCAD, right?
Sure. That would be incredible. And the fun, they've actually brought Alias Sketchbook Pro and some of these other high-end drawing applications to iPhone. So to put this kind of all together, the idea here is that the interface is a form. And the forces that are acting upon it are the forces of the computer, which have these same four fundamental dimensions: viewport, bandwidth, context, and power, and the human side constraints. And I want to talk a little bit about each one of these, noting that the dimensions of the environment, which we've talked about already, viewport, bandwidth, and context were introduced to the blogosphere by Jeremy Keith. And what I would really like to improvise or add in this talk is the concept that power is also an important constraining factor, and that you can't only think of viewport, context, bandwidth, and power from the standpoint of the machine. You have to think about those same things from the standpoint of the human being that's interacting with the machines in order to get a complete picture of the forces that are acting on the interface. All right, so some quick comments about each one of these dimensions. Okay, so viewport is pretty obvious. I don't think we need to motivate that further. Bandwidth falls into a couple of different categories, all of which have different average throughputs related to them. So cloud to device, intra-device, and to device. And in intra-device, we're talking about the buses, for instance, the CPU to GPU bandwidth. Context, we've talked a lot about, and we're going to give a precise definition in a moment. And finally, the power wall. And the idea here is that if you want to carry a device in your pocket and not burn your hand and also have a battery life more than 5 minutes, the power envelope of mobile devices is vastly constrained as compared to desktop devices. So now the question is, what are the corresponding constraints on the human side of things? And I think this will get to answer your earlier question about stage processing. So the first thing, which Furness actually makes note of in his 2006 paper, is that vision itself has a focus plus context structure. So what this diagram actually shows is, in proportion to the distance from the fovea, how many the resolving power of the eye. And what we actually see is that at high acuity, you can only resolve about 5% of your visual field. And the way that this plays out is that 50% of your so-called brain pixels are dedicated to only 5% of your visual area. And the important thing that I want you to notice is that this has a focus plus context structure. And the idea here is that there's an area of very high acuity where we're showing all of the detail that's available to us. And then very quickly, as we move out from the center of the eye, the acuity drops very sharply. Now we're going to talk about bandwidth from the perspective of stage processing and our working memory sizes. So the idea in stage processing is pretty simple, and it says that in order for human beings to acquire information, the information needs to pass through 3 stages. And those stages are sensory, short-term memory, and long-term memory. And sensory, the sensory input channel is extremely volatile. It can take in about 110 bits per second. And if information on the channel is not attended to, immediately it doesn't graduate to the other channels. The important thing about short-term memory is that we have visual and verbal working memories, which can hold very volatile nexuses of meaning that have about 5 to 7 chunks of information in them. And finally, there's long-term memory. And the important thing to see here is that we move from very fast structures that process at low volume to very slow structures that process at high volume. And those of you who work in hardware and are familiar with cache-only memory architectures will see that computers are structured the same way. You have your relatively small on-chip fast caches and graduating all the way down to the hard drive, which is relatively slow. Yes?
Isn't that magic number 7 plus or minus 2 stuff a little bit of a red herring? Because you're not keeping things purely in memory. What you have an external representation in your device. And so it's a completely different thing that has something totally memory resident without external cues.
Yeah, so I think your point is that there is as much information in the world, at least as much information in the world as is in your head. Probably a lot more. But I think from the standpoint of motivating, so when you're learning a new interface, certainly your working memory limits are going to come into play. And you're always dealing, I mean, this still does a great job of explaining why interruptions are so expensive, because the caches are so volatile. And it takes time to bootstrap to those 5 or 7 meaningful chunks. Okay, so context we're going to define in a moment. And the next thing I want to do is talk about power in the context of the human being. And the idea here, this is from, I think, a well-known paper in information foraging theory by Karve et al. In 1994. And what they wanted to show here was that the cost of doing work in a hierarchical office is a function of time, or more generally, energy, and the number of documents that you want to work with. And what they show essentially is that on your desk, you can work with a small number of documents, but you can do it very quickly. And then with your desk file, you can work with more documents, but it costs you more, and so on and so forth, all the way up to the filing cabinet. And this is pretty much the same structure that we see in moving from sensory inputs to our short-term memory structures and our long-term memory structures. And the idea here is that there are 2 ways to drive improvements. One way is for a fixed number of apples, or for a fixed number of documents, you make them available at cheaper costs. So 5 apples go from the cost of $1 to $5, or alternatively, for the same dollar, instead of getting 5 apples, you get 7 apples. And that was their original motivation in creating this, which is called the cost of knowledge characteristic function, was to help people reason about improvements across systems. And we're going to see how this relates to mobile design in a moment. But the thinking here was essentially that we have abundant information and scarce time and energy. And now, given that we want to get to the right information, how do we budget our time and energy? And I want to kind of cast this curve in a more modern context and talk about a hierarchical office that's built off of a suite of devices. And so here you have your handheld device, which is very quick to access, but relatively less capable, but you always have it with you, right? Then you have your notebook or tablet devices, and finally, a more complicated desktop device here. And what I want us to think about here, I want you to think about this hierarchy of devices in terms of a couple different scenarios. So kind of run this thought experiment in your mind. So you're at the mall, and you get an event invitation over email. Can you do it on your iPhone? Probably, yes or no. You get a yes/no question over email. Can you do it on your iPhone? Probably. Your best friend asks for marriage advice. Do you really want to deal with the iPhone keyboard in that case? You need to buy, excuse me, there's a typo there. You need to buy flowers for Mother's Day. Do you really want to surf, let's say it's not Amazon.com, because they've done a good job of retargeting their site for mobile. Do you really want to do Google Shopping? Or another site that isn't properly retargeted for mobile to do your shopping? Or now the coders in the room will get a kick out of this. You broke the build and you need to submit a hotfix. The chance of you doing that on your device, on your handheld device, are pretty small. And what I want to introduce here is the concept of the just mobile difference. So those of you in psychology are familiar with the just noticeable difference. And the just mobile difference is the threshold at which 50% of human subjects will switch devices. And the important thing which I want to draw your attention to here is this is an extraordinarily important thing to know. On a per task basis, which devices are best optimized for completing that task? Because it tells us which features to add, remove, or improve on a device, which is a very important thing for product teams to want to know. And so the idea here is that if you are below the just mobile difference on a device, you're doing a good job for that particular task. If you're above the just mobile difference, which means that people are more likely, 50% likely at least, to switch devices to complete that task either needs to be repurposed and redesigned for mobile, or needs to be taken off the device. And the idea here, I think, which was suggested by yourself, was that it is not sufficient to take the same layouts and the same user interfaces from desktop and simply shrink them down to work on a mobile device. It just doesn't work. And what we've seen, in fact, is what the large manufacturers have had to do in the case of iOS, in the case of mobile web, which requires an entirely different set of CSS, and then in the case of Windows Phone 7, is take their interfaces and completely redesign them. All right, so as promised, I want to give a working definition of context, because that's been an important element that we've talked about today. And it turns out that a literature search is not particularly helpful in this regard. And the acronym that we use at Cool Iris is STIR. And the context is kind of the aboutness of an event, or the items that surround the focus. And the way we think about it is context has 4 dimensions. It has space, time, interest, and relationship. And the interesting thing to note is that some of the major social networking services, if you look at them, they have tendencies that line with one of these single dimensions of context, right? So Foursquare tends to be heavily focused on the space dimension. Twitter, heavily focused on time. Dig, we have a community here that's built around interest. And finally, relationship. And we think the important thing here for communication platform designers is not to let any one particular type of context dominate the interface, but to have a general understanding of when users would benefit more from having a view that's slanted towards one of these particular dimensions. And in fact, if you look at, for instance, the expanded view of a tweet on Twitter, you can kind of see all these different types of information staring back at you. So on the one hand here, we have the interest, or the subject matter, which is reflected in links and the content of the tweet in hashtags. We have time. We have space. And finally, we have relationship. A lot clearer on Facebook, but on Twitter, whenever you pivot to an individual, you see all the people who are similar. All right. So the last piece that I want to talk about here, yes.
I'll ask one final question.
Sure.
What about the roles of goal and task in context? It seems like when people are doing things, the overwhelmingly important thing is what their goals are and how they're trying to accomplish those goals.
I think the simplest thing to say is we can think of the task as the focus and the goal as the context. And people have different strategies like opportunistic refining and backchaining that they use to chain tasks together to complete a goal.
Just think about it not being included in your definition of context. Whereas it seems that for a lot of things you do on devices, it's the overwhelmingly important thing.
I got your point, and I think we capture that through the interest dimension. So the interest is like the general semantic or mental approach aspect of context. Yeah. Okay, so the last piece I want to talk about in order to motivate privacy and sharing is the difference between the way that we have designed online social networks and the way that human beings are designed to function in social groups. And if we go back to the beginning of the talk, we talked about looking for the misfits between our form, which in this case is the design of the social network, and the context, which in this case are the natural social tendencies of the human beings that are interacting through the social network. And so there were a couple of results I want to go over with you. The first thing was a researcher by the name of Adams at Google did a very fascinating study called The Real-Life Structure of Social Networks. And he had a couple of important findings that I want to go through, and I want to add a couple of observations there. So first of all, people tend to interact with 4 to 6 distinct groups of about 10 people. And there are different tie strengths within a person's social circle. So as a rule, people have 2 to 6 very strong ties, and the rest of them are all weak ties. Does anyone start to see the mismatch here? By comparison, the way that Facebook and Twitter work as carte blanche broadcast platforms doesn't match at all this small group mentality. And they have taken a higher dimensional space, which has a lot of subtlety to it, right? There are certain status items that I only want my family to know. There are certainly certain status items that I only want friends who are over a certain age to know. And these interfaces are not really designed to articulate those differences. And so the first observation is that the interfaces that we're working with today are not optimized for groups or for varying tie strength. And as a result of that, we get what are called violations of sharing intent. And Majeski et al., earlier in the year, they did a study on 65 Columbia students. And what they found out was that for each of these 65 students over a certain period of time using Facebook, had at least one sharing violation. Now, what is a sharing violation? There are 2 kinds. I like to call them undersharing and oversharing, and they're pretty easy to understand. So the idea in undersharing is that there was somebody that you, in retrospect, you would have liked to include, but you failed to include them on the communication. And oversharing is, for instance, a teacher at an elementary school who also has friends who, for instance, work in the adult entertainment business and doesn't realize that when she comments on one of their posts, all of her students can now see that same post. Right? So that's an example of oversharing.
Or a member of the House of Representatives.
I think that's a very apropos example, right? And so the idea here is when people become conscious of oversharing, self-censorship is what results. And we're going to tie this all together, and what I'm going to do when we finish this thinking around the dynamics of actual social groups versus our interpreted interfaces for social networking, I'm going to show you a demo of one of our new products which tries to solve some of these problems. So many of you will be familiar with this concept of Dunbar's number, which falls somewhere between 100 and 230 and is typically averaged out around 150. And what Dunbar was trying to do was introduce a cognitive limit on stable group size. And so this number is intended to constrain not just the total number of individuals that you know, but the total number of individuals that you can maintain a stable relationship with and also know how they all relate to one another. So there's a quadratic explosion there because you don't just have to know the nodes in the graph, but you have to know all of the edges in the graph. And the theory is that this is a function of relative neocortex size, and if you go and you look at different mammals and you look at the neocortex size, you can roughly plot that one-to-one with the size of their groups. So why does this matter? Well, nominally, we have a social graph of 300 or 500 people or whatever that are, sometimes many more on Twitter or on Facebook. But the effective social graph, the number of people that you actually interact with, is considerably smaller than that. We're going to look at some examples in a second. So what does it all boil down to? I think the central problem here is undersharing and oversharing, excluding people unintentionally or unintentionally including people. And the important realization here is that we need social communication platforms that are built around small groups and ad hoc groups. And the idea behind ad hoc groups is that we take into consideration the sense of strong versus weak ties. I'll give you an example. Let's say that you order something from Amazon.com and you need to correspond with a customer service representative. For a very short period of time, that relationship is very important, but the idea of friending them on Facebook is totally foreign. But it's still important to have some kind of formal relationship with them through a computer system. And the next piece that we need are, of course, precise privacy models, and we're going to talk about one model for that. So Lee et al. In 2011 gave us this mantra, which is the elements of privacy are the audience, who you're broadcasting to, the actions that each of those can perform, and the artifacts, so the elements that you want to control the privacy around. And they also introduced this concept of explicit versus implicit trust. So explicit trust is you want to actively friend someone on Facebook. That is an explicit trust model. You want to follow someone on Twitter. That is an explicit trust model. But the idea here is that suppose 2 of us are not friends on Facebook, but we happen to comment on the same post. Have we established some form of implicit trust? Suppose that we both know the same people, 2 of the same people, 3 of the same people. To what extent does that now imply a relationship between these 2 people? And I think the next generation of social networks will at least start handling these questions, and you expect a kind of transitive decay. If we both know the same person, that is a stronger implicit tie than if I know someone who knows someone who knows you. Is that fair point? Okay, last comment. Another opportunity here, I think we have traditionally tackled this problem, and Facebook is starting to introduce groups. So people are starting to get it. I think the difficulty is that the de facto understanding of the platform is that you have this flat circle of friends who are all equally important.
Is that where the share button is going? Like if you share, you only share it with a group of people?
I don't think it's the share button. I think it's the little lock button that you have to open to articulate different groups, because when you share something, you're actually sharing rebroadcasting to your social graph.
But can't you choose the number of people?
You can, right? But I think you do that with the lock icon. Okay. Right. And so I think the untapped opportunity here is this concept of one person, but many different personas, many different facets to that personality. And we tried to tackle this so far by having a single individual who belongs to multiple groups, but it's also worth thinking about a platform where you have a single person, and the platform as a first-class element supports that person having multiple facets and interacting with distinct groups of people. What people do today is they just tack. They create another Facebook account, create another Twitter account, and that requires them essentially to duplicate all of their data. So the flip side to this problem, and I think a good place to stop because I have a live demo I'd like to do for you, is the content discovery problem. So the other side of oversharing and undersharing is overdiscovery and underdiscovery. And I'd like to party off Ethan Zuckerman's talk from CHI 2011, and he made this observation, is that in general, there are only 3 methods that we can use to discover content. So the first is purely curated content, and this is how the New York Times works. And the Times decides what needs to be on the front page, and the Times is taking an editorial view of things and says, these are the things you need to know, and ranking them in order of importance. The next is search, so this is push. The next is search, which is an entirely pull-based model. And the world that we're living in today is the world of likes. And this is kind of a combination between push and pull, because the items that you like, you are pulling towards you, but now the ranking algorithms on Facebook, for instance, are going to push content to you based on the items that you pull. And this has a couple problems. So I think the most stark representation of that is what Mark Zuckerberg famously said, and that is, it may be that a squirrel dying in your front yard is more important to you than people dying in Africa. And this is really something startling to think about. And the fear is that through systems that are exclusively based on liking, people will start to see a view of the world that is dominated only by the things that they're interested in. And the thought that I want to leave you with before going into our demo is that this also has a focus plus context structure to it. And I want to talk about that for a second. So we can think about curation as the assignment of an a priori importance to an element in the world. Search is, in some sense, your focus. And like is the assignment of an a posteriori importance to an element of the world. And so what we get is the sphere of influences model. And the idea here is that each of the topics in your world are represented by towers. Let's say cell phone towers. And in proportion to their size, each of those towers exerts a sphere of influence. Now, where you choose to stand in that world dictates the focus. And the strength of the surrounding spheres of influence dictates which spheres of influence, which elements with high a priori importance will make it into your focus. And the only thing we need to do to modify Furness's formula is, instead of API just standing for the a priori or global curated importance of the items, if we now add or blend into that the effect of the things that we've liked, we have a very good model for a transparent set of algorithms that show us what we're interested in, but also don't fail or don't occlude the broader world and some of the more important issues that are surrounding us. And so this general problem here is one of under and over discovery, and the solution is algorithmic transparency and control. And I think it's an open question for the community. How are we going to provide control to people? And do outlets like Facebook, where people are spending a vastly greater amount of time than they're spending reading the world news, do they have a social responsibility to inject globally important topics into the discussion and into people's needs?
Or what about Google doing the same thing? I guess there's kind of a recent discussion of different search results for different people.
Sure. So finally, I have an in-person demo for you all to try out on some iPads that I brought with me. But I would like to show you a video for the benefit of the people who are watching remotely. It's quick. And this is our view of how small group sharing and ad hoc group creation should be done at Karve.
This is a demo of our next generation service that shows how instant media sharing can be and the power it delivers. Here you see photos taken with LiveShare on the mobile phone instantly show up in LiveShare on the iPad. Photos, videos, text, and articles from multiple devices can be
Cache.
It's curated for us.
No.
sharing can be and the power it delivers. Here you see photos taken with LiveShare on the mobile phone instantly show up in LiveShare on the iPad. Photos, videos, text, and articles from multiple devices can be pooled into a shared content experience.
Hey guys.
Living up to our name, Live and Share, this is a demo of our next generation service that shows how instant media sharing can be and the power it delivers. Here you see photos taken with LiveShare on the mobile phone instantly show up in LiveShare on the iPad. Photos, videos, text, and articles from multiple devices can be pooled into a shared content experience.
Hey guys, that was awesome. Wish I could have been there. See you this afternoon.
This content is synced instantly across devices.
Hey guys, that was awesome. Wish I could have been there. See you this afternoon.
Contextual sharing also carries over to consumption, where maps, videos, and other articles and web pages can be viewed inline without losing context in the app. LiveShare's personal messaging allows users to share in context of what's important, whether it's with one individual, a few people, or the world. The app also enables the user to create new shared streams around a certain context. The user can select multiple images and simply drag and drop them into a stream. This is what we believe the personal messaging experience should be as the future of visual communication.
And I have some iPads with me. I'd like you guys to be able to try to share in real time in a small group.
Thank you everyone for coming. We're a little later than normal. We will do that sharing out in the hallway with the cookies and soda. Are there any last shots that somebody that hasn't asked a question would like to ask? Well, in that case, it was fantastic.
Oh, okay,
Really good.